Hello and welcome to our lesson today, the 7th grade lesson, lesson 8-2. We are in topic 8. We're into our lesson 2 right now. Today we're going to be talking about proportional relationships and graphs. You went over proportional relationships a little bit yesterday, and we're going to move in today to actually graphing those relationships. But let's go ahead and start out with our anticipatory set. I'm excited about our anticipatory set today because I was thinking about what I was going to talk about, and what I came up with. I don't know if anyone's ever heard of or played this game ever, but it was called Math Blaster, and it was like the coolest game ever. When I was going through school, Math Blaster, it's like you're this little spaceman and you'd have to go around and solve problems and do things. But one of the things that we were talking about, one of the things that you had to do was there was an alien invasion happening. And so you were some astronaut guy, the hero of the game, who was trying to save everything. And what you needed to do was you needed to stop the aliens from coming in and abducting people. So what you did in the game was you saw a screen like this, and there were a bunch of people standing here. And they were hanging out, but they were very scared because the aliens were coming. And then what you had to do was you were in control of what the game was calling a gravity gun. This gravity gun sort of just looked like that. It had something like that. And your character would run in and then sit in a little chair right here on the gravity gun. And you had to protect your people from being abducted by aliens. So what would happen in the game is that these alien ships would come down and then they would hover. They'd be there, they'd have their lights on, they'd be there. They'd have this little thing on the bottom of their ship. And what you had to do during this was you had to find an equation that would shoot your gun and hit the alien. So the alien would go away. Now, you only had a very little bit of time to do this because you could see there's this little beam that would be coming down from the alien ship, and it would tick down. If you took too long, it would take this person and would abduct them. And what you needed to do was you needed to figure out what the graph was, and then you had to shoot your gravity gun. And your gravity gun sort of shot out a thing like this. It would hit the ship, and the ship would go woo and go crazy and fly off in a different direction. Now, you couldn't move your gravity gun up this way or down this way. You had to shoot from this area right here. And you'd always have to shoot, and sometimes the aliens would drop in from there. Sometimes they would be here. So you would have to adjust how your gravity gun was aimed. So I always thought that was one of the most fun games I ever played, at least ones where I was teaching you math. And so that's sort of what we're going to talk about today. And what the main thing we're talking about is right here. I couldn't move this gravity gun at all because the skill they were teaching us in that game was about the origin. We're going to go ahead and talk about that a bit. So let's go ahead and get started. Hopefully, maybe if anyone's ever played Math Blaster, you know what I'm talking about, but that was a fun game. So let's go ahead and write down our standard for today. And our standard is going to be 7.RP, ratios and proportions, 2d. So that is our standard for today. And this standard says, explain what a point xy on the graph of a proportional relationship means in terms of the situation. with special attention to the points 0, 0, and 1R, where R is the unit rate. All right, so that's our standard for today. Let's go ahead and break it down a little bit before we get into our actual work here, okay? Explain what a point xy on the graph of a proportional relationship means in terms of the situation. Now that's pretty simple. It's just saying that we need to understand what a point means. Xy, what does that mean? We'll get into that. Then it says after that, with special attention to the points 0, 0, which, if you are realizing that right now, is where my gravity gun was always located, at 0, 0. This is what we call the origin. And I know you know that from years past, but it's always good to have a little refresher in there. And 1R, where R is the unit rate. So when you find, remember, we did this the last lesson I videoed for you with the workshop. We talked about these unit rates. Unit rates is when you get to a point where X is 1. You have, for one quantity, you have a value. So that's our standard. Let's go ahead and get started in our input. And we're going to go ahead and have 2 language of the discipline today. So the first one is going to be proportional relationships. A proportional relationship. And what is a proportional relationship? Well, a proportional relationship, said this way, 2 quantities are proportional if y is a constant multiple of x. So 2 quantities are proportional if y is a constant multiple of x. Now, what does that mean? Let's figure out what that means. Example would be that the equation y equals 4x shows a proportional relationship between x and y. So when we're looking at this here, it's saying, this equation is saying that y equals 4x. Y will always equal 4 times x. So no matter what numbers you're putting in there, it needs to satisfy this equation by saying that y always will equal whatever you put x here times 4. So the quantity y, let's write that down, will always be 4 times that of x. And just down here on the side, let's go ahead and prove that. If you have y equals 4x, let's just substitute for the lowest number we can find here. Let's just say that 4 times, and we're, instead of putting x, we're going to put 1. Now 4 times 1 will equal 4. Okay, so that proves that equation. So this is a proportional relationship so far. Let's try it again. 4 times, what's next? 2. equals, what's 4 times 2? 8. So we are setting up that proportion. It'll work every time. The proportional relationship shows that if x equals 1, y equals 4. If x equals 2, y equals 8, and on and on and on. Okay, our next language of the discipline is going to be one that we've already done, but I'm going to write it down again, and you're going to write it down too, is unit rate. What is a unit rate? And a unit rate, yeah, I know we already have it down in our notes. Oh, move that up a little bit. But a unit rate is the rate for 1 unit of a given quantity. The rate for 1 unit of a given quantity. So, for example, you could have something like 3, 1. We could say 40 miles per hour, because that means 40 miles per 1 hour. So that's our unit rate. I know we've gone over that already, so we're not going to spend too much time talking about it. We're going to move right along and get into our input. Now, I always liked this kind of math more because this math made more sense to me. I'm much more of a visual person. So for me, the spatial elements of graphs really stick out to me. So let's go ahead and put our flower for some details. And let's see how you feel as well with these graphs. So let's start first with, when is a graph proportional? There are 2 rules for when a graph is proportional. So I'm going to go ahead and write our rules icon down right here. And then I'm going to go ahead and put the 2 rules. And the 2 rules, now these rules will always tell you whether a graph is proportional or not. Rule number 1, the line is straight. Rule number 2, the line passes through the origin. Which is 0, 0. X equals 0, y equals 0. So those are the 2 rules you need to look for when you are determining whether a graph is proportional or not. So I'm going to go ahead and write a few example graphs out, and we're going to go ahead and decide which ones are proportional and which ones are not. So I'm just going to make these little graphs here, and this one will just say 1, 2, 3, 1, 2, 3, and the graph will look like this. Okay, let me get the next one. This one will say 1, 2, 3 on the X, and this one will say 5, 10, 15 on the Y, and we will do that. Okay, let's get the next one. This one's going to be 1, 2, 3 on the Y, 2, 4, 6 on the X, and it's going to look like this. And finally, we'll say this one here, which is going to be 3, 6, 9 along the X, and we'll say 10, 20, 30 on the Y. And this one will look like this. Okay, so now looking at these, which ones of these are proportional and which are not? Well, we just need to make sure that they hit 2 rules. Let's see, first of all, which ones can't work because the line is not straight. This one is straight. This is an option. This one's straight. This is an option. This one is not straight. It turns halfway. That is not proportional. This one is straight. Okay, so now we have three options. Which ones are proportional? Now, which of these three are going to hit that second rule, which is the line passes through the origin. The origin is right here, so this one is proportional. The origin is right here, meaning this one is not proportional. It does not cross the origin. The origin is right here. This one is proportional. This one does, but it still is not straight, so it's still not proportional. So these are proportional graphs. These are not. Okay, I'm going to go ahead and move to my next piece of paper. And let's move on. We still have some details to go over. And this next part we're going to be doing is going to be when we use a table. So this is going to be using a table. Those of you who are more logical mathematical, you may enjoy this a little bit more. So I'm just going to go write out a table for us, and then we're going to use the data I put in that table to help us figure out our graph and figure out whether or not it's proportional. So let's start with time in seconds and heartbeats. So that's going to be our relationship, and we want to see whether or not this relationship is proportional. So we'll start 4 seconds. The heart will beat 6 times, 6 seconds, 9 times, 10 seconds, 15 times, and 12 seconds, 18 times. Now, if we have a table, the great thing about a table is that it easily gives us points on a graph. If you look right here, and I'll help us out with this, we're going to use time as X and heartbeats as Y. This gives us, and I know you probably know this already, but this gives us an ordered pair, XY, 4, 6. So this will give us 4, 6. Easy. So the next one, 6, 9. The next one, 10, 5. Oh, whoops, 10, and that's supposed to be 15. Yes, so sorry. And the last one, 12, 18. Now we can go ahead and draw our graph. Our x will go by 2. So this is 0, 2, 4, 6, 8, 10, 12, 14, blah, 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 blah. This one will go by 3s, 3, 6, 9, 15, 18, blah, blah, blah. Okay, and then we just chart the points that we know. So we have 4, 6. That means 1, 2, 4. Remember to make sure that you know what you're doing down here. And actually, I'll tag this as well. This is time, and these are beats. Okay, so 4 is right here. 6 is right here, and we put our first point. 6, 9. 6, 9. 10, 15. 10, 15. 12, 18. 12, and then 18. Now, we can sort of see this happening here. What we need to do next is we need to be able to connect these. So you just draw a straight line connecting all of these. And would you look at that? You're going to see that it is straight and crosses the origin. So it's straight and it crosses the origin. That means this is a proportional relationship. So that's the way you use a table to figure out if something is proportional. Let's go ahead and get a little even more logical mathematical by saying, what if now we're going to be using an equation? So we used a table. Now we're going to use an equation. So let's look at, I'm going to go ahead and write down two different equations, two different questions. Is y equals 2x proportional? And I'm also going to write down, is y equals 1/2 x plus 2 proportional? Okay, so we have two different equations that we're going to go ahead and figure out if they are proportional. Now, what you can do, and I'm going to go ahead and do it this way, you can go straight from the equation to the graph if you feel comfortable that way, because you know how the numbers are going to react. But what I like to do is I like to take it, okay, y equals 2x. Then I like to make a chart, x, y. And let's get these numbers out first. Now, this is a pretty simple equation. I won't have to do much math each time. But let's start with something simple, like x equals 1. If x equals 1, it's going to multiply by 2, which is going to give me 2. And that's what y equals. Okay, let's try a different one. X equals 2 now. 2 times 2 is 4. Y is going to equal 4. Let's try the next one, 3. 3 is now x. 3 times 2 is 6. So y equals 6. Okay, that's probably enough for now. Let's go ahead and draw a little graph and see if this is proportional. Okay, along the x, we're going to have 1, 2, 3, 4, 5. And here we'll have 2, 4, 6, 8, 10. Okay, there we go. So this is our origin. That's what we need to make sure it passes through in order for it to be proportional. Okay, so let's take a look. 1, 2. So one of our ordered pairs is going to be 1, 2. 2, 4. 2, 4. 3, 6. 3, 6. Okay, and then we just connect. And would you look at that? It goes right through the origin and it is a straight line. That means it is, yes, it is proportional. Okay, so then let's now look at the other one. Same thing I'm going to do. This one might be a little bit more complicated because there's a little bit more of a complicated equation, 1/2 x plus 2, but I'm still just going to try and go ahead and do it. X, y, make my chart. Okay, so let's again start with something simple for x. X equals 1. If x equals 1, we're going to multiply that by 1/2, which is going to give us 1/2. 1/2 plus 2 is going to give us 2.5. So y is going to equal 2.5, or I'll just say 2.5. Let's go with, maybe it'll be a little easier to use number 2 now, because if x equals 2, we multiply 2 by 1/2, which gives us 1. 1 plus 2 gives us 3. So y equals 3. Let's jump up and do 4. 4 is now x. 4 times 1/2, take half of 4 gives us 2. 2 plus 2 gives us 4. And let's go ahead and do 6. 6 times 1/2, it gives us 3. 3 plus 2 gives us 5. Okay, so we've gotten a couple of our values. Now let's go ahead and make our chart, or make our graph, sorry. Along the bottom, I'm going to say 1, 2, 3, 4, 5, 6. Along the top, we'll do the same thing. 1, 2, 3, 4, 5, and that's 6 up there. Okay, let's go ahead and get our ordered pairs in and see if this is proportional. 1 equals, or 1 is to 2.5, which is 2.5. 2, 3. 4, 4. 6, 5. Okay, now let's go ahead and connect these dots, try and keep it straight. Okay, it is straight, but it does not hit the origin. It crosses the y-axis at 2. It misses the origin, so this is no, it is not proportional. Okay, let's move forward. Last thing we're going to do before we get to some modeling is going to be unit rates. Because one of the things the standard said is that we need to be able to find the unit rates. Now, to find a unit rate, x must equal 1. Now, oh, I'm so sorry, you can barely see that. There we go. Now, what we can do is we can just look at this. If we look up here on this one, look on the graph. X equals 1, y equals 2. So our unit rate for this one up here is going to be 2. So you can definitely do that. That's a pretty simple way. You just look on the graph, you see where x equals 1, and you're good to go. Let's also see if we have just an equation. If it's an equation, it's also pretty easy. Y equals 7x, something like that. Then, to find the unit rate, all we know is that we need to get x to equal 1. Let's just substitute. Y equals 7 times 1, which is y equals 7. So this will be our unit rate. And finally, let's say I have just a graph. Just a graph based on anything. On the side, 5, 10, 15. On the x, I'll go 1, 2, 3. And let's say this is the graph. Now, again, we just look. Here's 1. X is 1. What does y equal? So this would be 10 to 1, 10 to 1, or just 10 as our unit rate. So pretty simple. I know we already know how to find the unit rate, but something good to know. All right, I'm going to jump over and get to one more piece of paper here. We're going to go ahead and take a look at some modeling. Oh, I ripped the top. Oh, frustration. Okay. Modeling. We have a couple questions here, and then we're going to get our guide and independent practice for today. Okay, so for today, for modeling, let's start with number 1. Number 1 says, does y equals 7x minus 2 show a proportional relationship between x and y? Okay, so if that is our question, we have an equation. We can go ahead and turn our equation into a chart very quickly. Okay, on one side, we're going to have x. Again, we're going to do the same thing we did before. We'll just substitute an easy one in, 1. 7 times 1 gives us 7, minus 2 gives us 5. So y will equal 5. Then let's go ahead, go to 2. 2 times 7 gives us 14, minus 2 gives us 12. Then we'll go to 3. 3 times 7 gives us 21, minus 2 gives us 19. And finally, 4. 4 times 7 gives us 28, minus 2 gives us 26. So we used our equation to go ahead and get our chart. Then we'll take our chart and put it onto our graph. And we'll just do down here, we'll go 1, 2, 3, 4, 5. And along the y-axis, we'll say 5, 10, 15, 20, 25, and then up there is 30. Okay, let's go ahead and put let's put our graphs in, or let's put our points in. So we'll start with 1, 5. So when x equals 1, y equals 5. Okay. 2, 12. 2, 12. Out there. 3, 19. 3, 19, about right there. 4, 26. 4, 26. Okay, and then we go ahead and connect. Now, what's difficult sometimes when you look at a graph like this is I'm not the best at drawing. And I might have a little confusion saying, oh, maybe I just didn't draw the line straight enough, and maybe it did actually hit the origin, because right here it's showing it does not. But what if it did? What if it's just me not being that great at drawing, having a little bit of problems? Well, let me show you a nice, easy way to check. Now, based on this graph, I would say that this is not proportional because it doesn't go through right there. But I'm going to show you a way that you can always check and make sure that you are good. And that is, we'll go back to our chart, and instead of starting with x equals 1, remember, the origin is 0, 0, meaning x and y both need to be 0. So if I say that x is 0, to make it proportional, y would have to be 0 as well. So let's try it. And I'm actually going to write it out this time. Y equals 7x minus 2. Okay, we're going to substitute x as 0, minus 2. So now y equals 7 times 0 is 0 minus 2. Y equals negative 2. So when x is 0, y equals negative 2. That is not proportional. A proportional relationship would have x equals 0, y equals 0. So this would be not proportional. All right, and let's now move on to number 2. Number 2, we'll jump a little bit back into football. Love talking about football. So each touchdown in a football game is 6 points. Is this relationship proportional? What is the unit rate? Okay, so we have 2 parts to this question. First of all, is this relationship proportional? Now, like I showed you up here, you could go ahead and solve, but right now we don't have an equation. We could write an equation, but I'm just going to go ahead and go right into making my chart. So one side we're going to have touchdowns, how many are scored, and that's going to be our x value. Our y value is going to be points, because each touchdown gives a certain number of points. So if we're going to go through, it says each touchdown is 6 points. So that means 1 touchdown is going to give us 6 points. 2 gives us 12. 3 gives us 18. 4 gives us 24. So now let's take our ordered pairs and let's go ahead and put them onto a graph. On the bottom here, I'll just say 1, 2, 3, 4. On the top, we'll count by sixes, 6, 12, 18, 24. And remember that this is our origin of 0, 0. Okay, now I'm just going to fill in my points. 1, 6, 1, 6. 2, 12, 2, 12. 3, 18, 3, 18. 4, 24, 4, 24. And then I connect them. And look at that. I see it pass right through the origin. Yes, it is proportional. Okay, now the next thing we need to figure out is what the unit rate is. So the unit rate is when x equals 0. Oh, sorry, equals 1. So our unit rate here, we need to be very careful with what we're talking about. We're saying that the x value needs to be 1 because down here are the touchdowns. Here are the points. So it's very easy to realize, oh, okay, here's x, here's 1, so 6 to 1. The unit rate is 6 to 1. However, we need to be able to explain that, especially when it's a word problem. So if it's 6 to 1, that does not mean 6 touchdowns to 1 point. That wouldn't make sense. It means 6 points to 1 touchdown. You need to make sure that you are ordering it correctly. You know what value is in what place, the x or y. So we are saying every touchdown is 6 points. Make sure you're not writing down every point is 6 touchdowns. That would make football a lot more boring. All right, so that's it for the lesson today. I'm going to go ahead and write down our guided and independent practice. Our guided practice is going to be lesson 8-2, guided practice. And remember, that is posted on your Pearson site. Our independent practice you are going to go to Front Row Ed. You are going to go to Ratios and Proportions. You are going to go to Assigned Practice. And then you're going to go to 7.RP.2d. And that is your work for today. Good luck, have a great day, and go Buffs.